Good morning again, boys and girls. We're going to continue with one-step equations. So this is in your packet, and it is after lesson or cool down 6.6. So I'm actually going to start at the bottom. I want you to do as many of these on your own as you can. So I'm going to give you another example of an addition problem and a subtraction problem. So this is one-step equations. And as a review, when you're solving for addition, you're going to use subtraction. When you're solving for subtraction, you're going to use addition. When you're solving for multiplication, you're going to use division. When you're solving for division, you're going to use multiplication. So we are employing the opposite operation in order to solve for our variables. And once again, a variable is a symbol that stands or represents a number. All right, so let's start with 3 equals z minus 11. So if you remember what I told you before, is you're looking for the sign that follows or comes in front of the variable that goes with the number. So this sign right here goes with this number. I could write this a different way. I could write 3 equals negative 11 plus z. This is what I'm looking at in order to determine how to solve this problem. So I'm going to take it just the way it came. First thing I'm going to do is I noticed already that this is a negative. So my opposite is a positive. Okay, I'm always looking for this to be a 0. That again is the identity property of addition. So if I have negative 11 way over here on the number line, and I want to get to 0, I'm going to get positive 11, or I'm going to add positive 11 to get to 0. This becomes 0. 0 plus anything is still the anything. And whatever I do to this side, I have to do to this side. My equation has to remain in balance. So I'm therefore going to add 11 to this side. What I'm left with is 14 equals z. If I take this 14 and I substitute it into my original equation, you can see that that makes a true equation. So the whole point is to make a true equation. So let's go ahead and substitute 14. So I decided that z was equal to 14. I don't know why I did that. And we've done substitution already. So I'm going to put 14 where z is. Okay, and 14 minus 11 is 3. That makes my equation true. So I'm going to do one more. I'm going to do an addition one this time. And one that doesn't look quite as obvious. This is number 10 on your first page. So you have 4 plus a equals 13. So this says plus a, but if I use a to subtract, I don't end up with an answer. You can't subtract a from 13 because you don't know what a is. So I always need to look to see what my number is on the other side of the equation. This is a positive 4. When there's no sign here, it just means positive. So the ones with no sign or with a positive sign like this are positive numbers. So I'm going to use my opposite operation, and I'm going to do that on both sides of the equation. Positive 4 and negative 4 gets me to 0, plus a equals 13 minus 4 is 9. Now I'm going to go back to my original equation. I'm going to substitute a for 9 for a and see if I come up with 13. So 4 plus 9 equals 13. So cha-ching, true equation.